Welcome to video number 443. In this video, I'm going to explain the Shephard's lemma and the Roy's identity. After discussing the consumer's problem and constraint maximization of utility subject to budget constraint and constraint minimization of expenditure subject to utility constraint, we are now in a position to discuss the Shephard's lemma and the Roy's identity. So let me start with the introduction to Shephard's lemma and Roy's identity. We may look at this figure. In this figure, there is the consumer dual problem. On the left hand side, we had the primal function, and the right hand side, we have the dual function. In the primal function, we have the utility maximization problem subject to budget constraint, and then when we solve constraint maximization for x and y, and we plug the values of x and y into the original utility function, we get the indirect utility function, and by applying the Roy's identity, we get the Marshallian demand functions for x and y. On the other side, using the constraint minimization of expenditure subject to utility function, if we plugged in the solution values of x and y in the original budget constraint, then we get the expenditure function, and applying Shephard's lemma to the expenditure function, we get the Hicksian or compensated demand functions. So we will discuss this in greater detail. Let me start with the background about Shephard's lemma and Roy's identity. There are a number of ways to explore the consumer's choice problem and a related variety of ways of deriving demand relationships. We may summarize these various relationships to show how they all fit together. At the top of the preceding figure that we discussed in the previous slide, two dual approaches to the consumer's problem, that is utility maximization and expenditure minimization, are listed. Each of these results in a solution in which the final goal achieved depends implicitly on the parameters of the problem. Maximum indirect utility function and minimal expenditures depend on prices of all goods and the constraint of the problem, that is income or utility respectively. Utility maximization, which holds income constant, leads to Marshallian demand functions, and expenditure minimization, which holds utility constant, leads to compensated demand functions. So here is a detail about Shephard's lemma. In consumer theory, the Shephard's lemma states that the demand for a particular good I for a given level of utility U and given prices P equals the derivative of the expenditure function with respect to the price of the relevant good. That is, HI function of price vector P and U is equal to the partial derivative of the expenditure function with respect to price of Y, is the Hicksian demand for the ith good, where HI of PU is the Hicksian demand for good I, E is the expenditure function, and both functions are in terms of prices, a vector P of prices and utility U. Thus, Shephard's lemma gives a precise formulation for the demand of each good in the market with respect to that level of utility and those prices. The derivative of the expenditure function, E price of X, price of Y, and constant utility with respect to price. So the Hicksian demand for good X is equal to the partial of the expenditure function with respect to price of X, and that is equal to Hx of Px, Py, and constant utility. So this is the Hicksian demand for good X. Similarly, the partial of the expenditure function with respect to price of Y is the Hicksian demand function for Y commodity, and that is the function of price of X, price of Y, and the constant utility. Hicksian demand and expenditure function relate to expenditures minimization problem EMP just as Marshallian demand and indirect utility function relate to the consumer's problem. Now we discuss Roy's identity. Roy's identity is a major result in microeconomic theory, which has applications in consumer choice and the theory of the firm. This identity relates the Marshallian demand function to the derivatives of the indirect utility function, specifically denoting the indirect utility function by V of P and Y as the Marshallian demand function for good I can be calculated as follows. And xi of m is a function of price vector and y, and that is equal to the negative of the ratio of the partial of the indirect utility function with respect to pi to the partial of indirect utility function with respect to income. Or in case of two goods where y is income, x is a function of price of x, price of y, and income of the consumer, and y is the function of price of x, price of y, and consumer income. The small y in both these functions is the consumer income, where p is the price vector of goods, y is the income, and where the superscript m indicates Marshallian demand. The result holds for the continuous utility functions representing local non-satiated and strictly convex preference relations on a convex consumption set, under the additional requirement that the indirect utility function is differentiable in all arguments. Roy's identity is akin to the result of the price derivatives of the expenditure function give the Hicksian demand functions. The additional step of dividing by the income derivative of the indirect utility function in Roy's identity is necessary, since the indirect utility function, unlike the expenditure function, has an ordinal interpretation. Any strictly increasing transformation of the utility of the original utility function represents the same preferences. Here is an example. Let the utility function be given by the Cobb-Douglas form. The utility function is equal x raised to the power 0.5, y raised to the power 0.5. We may calculate the indirect utility function for this case as follows. The indirect utility function v of px, py, and y is equal to m divided by 2 price of x raised to the power 0.5, price of y raised to the power 0.5. And the Roy's identity states that the Marshallian demand function, which depends on price of x, price of y, and m, is equal to the partial of indirect utility function with respect to x, price of x, divided by the derivative of the partial derivative of indirect utility function with respect to income, and finally we get the Marshallian demand function for x is equal to m divided by 2px, where m is the consumer income and px is its own price. We may remember that here in this function, this y is equal to m. So these y and m may be taken as interchangeably. This is m consumer fixed income, and this is also consumer fixed money income. So this Roy's identity says that it is exactly the same result as solving consumers' problem of utility maximization subject to budget constraint. We may set up Lagrangian function which is equal to the original utility function times Lagrangian multiplier into the budget constant, where m minus px times x plus py times y. And if you take partial derivatives of this Lagrangian function with respect to price of x, price of y, and lambda, and solving these three equations simultaneously, we get x star equal to m divided by 2 price of x, and y star equal to m divided by 2 price of y, where x star and y star are the solution values of x and y commodity. This lambda in this problem may be thought of as the margin utility of income. To derive the compensated demand functions derived in video number 441 as 2 into price of x raised to the power 0.5 and price of y raised to the power 0.5 whole raised to the power 0.5 times constant utility given by u bar, and apply Shephard's lemma to take the partial derivative of expenditure function with respect to px. We get hx, that is Higgsian demand function for x, which is function of price of x, price of y, and constant utility, and that expenditure function is equal to u bar, that is constant utility, price of y raised to the power 0.5 divided by price of x raised to the power 0.5, which is precisely the compensated demand function or Higgsian demand function, which can also be derived by taking the derivative of the expenditure function with respect to price of x. Here is the conclusion. Of course, the computation involved using Roy's identity or Shephard's lemma may not always be this simple, but these techniques often offer the most direct route to solving the problems in the theory of demand. Thanks for watching this video. Kindly subscribe to the channel, and don't forget to click on the bell icon so that you can get timely notification about my other videos that will be uploaded for you. Thanks for watching this video. Kindly share various videos of this channel in various WhatsApp groups so that this could reach to the maximum possible number.